So we have seen the string data type, which is very essential data type. It is an derived data type. Now we will discuss about list as a data type. List is a very interesting data type because it can store multiple formats of data. It can store string information, it can store uh, other set of information like numeric, float, boolean, all different set of information can be stored. Even a list can store list within itself. So whenever we are talking about storing list within a list, we will use the list function. So list is an heterogeneous data type, which means that it can have multiple data types embedded into it. So it can have, as I told you, list can have list tuple dictionary inside a list. It can also have data types such as integer, float, character, all of it. It is not mandatory it should have only one. List can have duplicates. It is not necessary that you don't put duplicates. It allows repeatability of data. List is used, it can be changed. You can change a list if you want to change a particular value, if you want to change a certain set of value, if you want to add element, you can add it. So list is open for change. Elements are separated by comma. So the list elements are basically separated by comma, and list elements are enclosed inside a square bracket. So we have seen a kind of intuition of list in the previous few codes, but now we will discuss in detail about list, how it is generated, what is there inside a list, how we can definitely work on the list. So that's what we are going to discuss now with the help of a list. So list basically allows different operations such as adding new element, concatenating different lists together, indexing and slicing a list, and it allows us to have different numerical values. For example, if I have numerical data inside my list, so it allows me to find out minimum, maximum, length of the list. At the same time, it also supports operations such as membership operator like in and not in, to check if a particular value is inside a particular list or not. So we'll talk about a list here, which is there, which is the name of a book list. So there are three books here: Data Science with Python, Introduction to Machine Learning, Big Data, Hadoop. And the type of the list, type of the data type variable book list is a list here, and we can see there are three elements into this list. This is how it is created. It is created with the help of this square brackets here. This square brackets facilitates to keep everything enclosed inside a list, and you can see each of the element is separated by comma. So list can be enclosed into a square bracket. So we'll talk about list operations. So here we have a list, and there are two lists actually. First list is the name of the books, data science book, and the second list is the name of novels. So there are three novels and three books. So we can concatenate also two lists by using the plus operator. So we can concatenate by, if you concatenate two lists, you can see that the list A and list B is getting kind of added. We'll try to see it with the help of a demo here. So we are going to talk about a list data type now. So suppose I have a list L1 which has value say A, B and say C. So there are three elements inside my list, and here in L2 I have say P, Q, R. So L1 and L2 are my two lists. I have created my own list. I have put some value into it. These are my choices. I can put anything here. So these are my choices. Okay, I'll press shift enter to run it. And if I talk about L1 plus L2, you can see A, B, C, P, Q, R is a concatenate version of the list. If I want to add a new element to L1, say if L1 is there, if I want to add a new element, So I can use append, and I can add that element. Say if I want to add a new element D suppose, and L1 will now be getting a new element D, which is permanently stored at the end of the L1. So list also supports different kind of functionality. It is an iterable. You can see it has multiple element. It is a combination of multiple elements within it. I can place number as well as string, all of it inside a list. So we'll talk about some list basic functionality, as we've seen that what is append, what is how we can concatenate the list. Now we will talk about sorting a list. So what is sorting a list? Sorting a list is about arranging the list data into an ascending order. Now if I talk about this data here, there are two, this is L1. L1 has ABCD, which is already sorted. I will do what? I will randomly assign some values to L1. Okay, new L1 I will create. So say I'll take, I have created a new L1, and I have made a mistake. I'll just put, okay, 90 or something, some number between that. And here if you talk about L1, the elements are not at all kind of sorted. These are kind of random. You can see it is increment, like higher number, then lower number, then again higher number. Like these are not sorted, these are randomly data. We can use sort function to sort the data in okay, so if I use sort data, it is sorting my list into a newer list, which is a sorted version of a list. So basically it will sort my original list in ascending order. Now sort also has key and reverse is equal to false. So reverse basically helps us to sort the data. If I use reverse is equal to true, so it will sort but in descending order. So you can see it is sorting in the descending order. Now this is to sort a numerical list. What if I have a alphabetical list? So suppose I have a list L2, which is an alphabetical list, say A and sorry, not A, I'll put H, and then L, then I'll put K, A, Q. I'm randomly putting all alphabets as I wish. I'll put B now. I'll put T. I will put Z here. So you can see this list is completely random. If I talk about L2, see this is a random list. Now L2 dot, if I'm using sort, let's see what happened. So it is sorting, it will sort my L2 in ascending order, A, B, H and all, everything will be sorted with respect to ascending order. Okay. Now let me take a third list L3, which is equal to L1 plus L2, and let's have a look at L3 now. Now this L3 is a combination of alphabet as well as numeric values. So it is a numeric values as well as alphabetical values. Now let's sort L3. Let's see what happens. Let's sort L3, and you can see it is not allowing me to sort. So list, we can create a list with multiple set of data types, integer, float, tuple, all different set of data can be there inside a list, but it cannot be sorted if the data is not consistent or if it is not uniform. So if I'm using alphabet, it should be alphabet throughout. If I'm using number, it should be numeric throughout. So we have seen the reverse function. We have seen how if it is a combined mixed list, it is not allowing me to sort a list. Now we will talk about the function sorted. Sorted function is an external function. It is not a list function. If I talk about list function and sorted function, let's try to understand the difference between the sorted and the list function. So let's understand all the list function for now. L3. So this is my list. So L3 dot sort, if I try to use sort function, this is how I can use. Now this sort function can be used only for list. Suppose I have some other, okay, it cannot sort it, okay, I'll use L1 dot sort, okay, so it is allowing me to sort. This sort is a list function. Now I'll try to explain you what exactly is this list function and which all functions are respective to that particular data. Now when we talk about data types in Python, every data type, integer, okay, so integer data type, when it was developed in Python, it was developed as a class. It was developed as a class, and there will be some functions respective to this integer data type. So it can be anything. Similarly for string, so in string also we have seen some functions, so it can be any number of functions. So it can be kind of upper, lower, we have seen all this function. So in Python, when Python was constructed as each and every attribute of Python was constructed as a single class. So integer class, string class, so the objects which are there in the string. So if we created the string, if you remember, string s, so s dot, if I am putting s dot and if I press tab, you can see different functions are coming, capitalize, case, fold, center. These all functions are basically string methods. These are methods of the string class in Python environment, or where Python was developed. When Python was developed, so in Python's development environment, these all functions are basically methods of string class, okay. Similarly, when I talk about L1 dot, so you can see different functions, append, clear, copy, count, extend, etc. These all functions are specific to list only. So these are list functions, okay. Now as I told you, sort function is used to sort the list. It will sort the list in an ascending descending order based on whatever is the value there. Now I was talking about sorted. Sorted is an external function, it is not a list function, okay. So if I use sorted of L1, it is sorting the list and returning me the list in an ascending order, okay. So sorted is a function specific to Python class, and in sorted I can put L1 list or I can put any iterable which can be used. You can see sorted has multiple argument, iterable, key, whatever key you want to put, and reverse if it is true or false. So we can use sorted as well. So suppose sorted, I have created the string s. Let us use sorted for s. Okay, you can see first of all it is sorting everything based on the values for first according to the string ASC2 codes. First round bracket is the first element, then second round bracket, then star 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 all together, then numbers have preferences, then p, and then ASC, according to ASC code these two symbols are important, then H, N, O, T, Y. You can see everything is sorted based on ASC code, ASC2 values of these codes. Now what are these ASC2 codes? ASC2 codes are the standard codes for each and every literal inside the string. So each string literal will be having certain set of ASC2 values, and based on that it is going to sort, or it can sort in the alphabetical value for only the string values. For example, if it is a string called okay, so Python program, if we are trying to sort it, okay, so if I'm using sorted over this, so ASC2 code is also arranged according to the alphabetical data number only. So according to the ASC2 codes, A will come always before G, H, M, N, O and all. Sorted is not specific to list. Sorted can be used over any iterable, but sort is specific to list only. So it is a list function. We have to keep it in mind. Now we can also sort in reverse order by keeping the parameter reverse is equal to true. We can just simply in the sorted we can put, you can see reverse is equal to true we can put, and it will be sorted in reverse order. But the problem with sorted is, even if you pass string, it is giving me list only as an output. So sorted basically returns a reversed or sorted version or alphabetically arranged data in either ascending, descending, based on whatever reverse parameter you are specifying. So this is sorted. Now we will talk about some specific functions, specific operations that we can do for a list. So as we discussed, list is an iterable. So as list is an iterable, it allows us to use membership operators over it. So I'll call out a list. Say I'll store this data as a list. Okay. I'll call this list as values or something. Now this values list, if I talk, these are some information. Now what if I don't know what is there inside this list? So I will, if I want to check if B is present in this list, so I can use if B in values. Okay, if I use it, it will tell me that yeah, B is not present. I can check, say, A. Okay, so it will tell me whether it is there or not. Okay, so this operation, using in operator, I can also iterate over, or I can check across any values present inside a list. Now the best part of using in operator is you don't have to iterate over each and every element and check for the presence of the data. You can simply use the in operator, and in operator will simply iterate on its own and tell you, okay, if this particular string is present inside this list or not. Okay, so in operator is valid in our list also. We can use not in also to see if a particular string is not there, a string A is not present inside my list. So not in also is kind of useful in this list function. Now we will also see how we can iterate over the elements of the list. So we can use a for loop for iterating over list. Okay, so see, these are my list, and I can use for loop to iterate. So for I in values, if I use, and I can simply use print I. Now understand one thing, in the previous for loops we have used for I in range of something something, say 1 to 10 I have used. So here in this range, if I talk about, this is a number generator range, and it is generating number from 1 to 10. Okay, up to 1 to 9 basically it will generate. So here I indicates numbers in an iterable range 1 to 10. Okay, so range 1 to 10 is nothing but a sequence of number from 1 to 10. That's why range is also an iterable. We discussed this earlier in the for loop. But now we are talking about we are talking about list. So values is a list. In the list values, I am iterating using the same operation, which means if I am using for loop, so I am using for I in, so I am using this membership operator in my list values. So my list is values. So for I in values, now I will hold values of these alphabets within this values list. So that's what the difference. So I doesn't indicate that it is a number. I indicates what is there inside this iterable. If this iterable is a list, so I will now become Y, T, R one by one. If you see, so I am printing Y. So initially Y is getting printed because I becomes Y. In the second iteration, T gets printed, R gets printed, and so on. I can specify the end parameter as something so that it will show the output into a single. So you can see Y is the first element inside my list. So I value becomes Y, and then I am printing the space. So the space will get printed. Then the second value is T in the list, and that's why T is getting printed. So this is one method by which I can print elements inside a list. Now there are certain operations inside a list. For example, finding the number of elements in a list, finding the maximum and minimum value of a list with numeric values, appending a new element to a list. We have already seen this, how to append a new value, how to remove all elements from a list, create a copy of the list, count the number of occurrences of a specified element, return an index position of an object, insert a new element to a list at a specified index, and reverse a list or sort a list. So these are some operations that we have seen. So we'll talk about this some of the new functions of this list specifically dedicated to list. Okay, so this is my list L1, and if I talk about max of L1, I can use max function. Max of L1, it will give me max. Now max of this list L1, I will just, okay, I'll just print this L1. This is my L1. Max of this list is 568. That's why 560 is printed. If I use min of L1, so we can see 1 is printed. We'll see that if max and min function are there inside my list class. In my list class, there is no function such as max. So max function and min function are not specific to list, but it can be applied over list. You can apply maximum and minimum over list to find out the max and minimum value. So this is the first case, and now we will talk about some additional functions of list. For example, append we have discussed. So when I'm using append, it can add one value to my list. Say I want to add 707 or something. So L1 will now have the value 707. Now we'll talk about some more functions. So L1 dot, you can see there are different functions, copy, count. So these all functions definitely add more value to your list. For example, pop. If I'm using pop, so pop will do what? It will remove element which is at the last position, and it will show the output as well. So you can see it has removed, it has popped out 707, and if you see L1, you do not find 707 as a last element. Now we have seen the list with respect to the append function, the pop function. We will also discuss about an additional function. Suppose L2 is my list. L2 is my list and L1 is also my list, okay, like this. If I want to extend this my list with an additional list, we can definitely use L1 plus L2. L2 can definitely add this list to an element. Like it is definitely extending my existing list L1 with L2. But if I want to make changes in L1 by adding L2, so I can use L1 dot extend function, L1 dot extend function to extend my existing list. So I want to extend L1 and L2 like this. So now it will make permanent changes in my list, which means my L1 has now become L1 plus L2. Okay, so that is the difference. L1 plus L2 can also extend the list, and L1 dot extend L2 will also extend the list. The only difference is L1 plus L2 will not make permanent changes to L1, but L1 dot extend L2 will make the permanent changes to L1. Now we will talk about L1 and some specific function for L1. Now there are a lot of different functions like count. If I suppose I want to count how many times a particular value is repeated, so that also is possible. I want to mention, okay, this count 1, so it will tell me, yeah, it is repeated only 1 times, and like that we can definitely use some other function as well. Count, extend, index. Now index is a very important function. Index can help you get what is the index of a certain value. For example, A. If I want to find out the index of A, the index position of A is 7. Now let's calculate the index of A. So it starts from 0 in Python. Any element, any iterable, the index actually starts from 0. So 0, 1, 2 and so on, 3, 4, 5, 6, and see, this is at 7th position starting from 0. So A is at 7th position. So L1 dot index can definitely help you to get the index of a particular value inside a list. Now we'll talk about L1. Okay, we'll talk about L1 dot okay, we'll talk about L1 dot, and we see the different functions are there. There is reverse, there is an insert function actually. We have seen append function, we have seen the extend function. So append is to add a new value at the end, extend is to add a new value at like add a new list or extend the existing list with a new list. Now we will talk about a new function, that is insert. Insert is very interesting because insert function basically accept two things, that is index and the value that you want to add. So if I want to add a value at say index position 4, so my current index position 0, 1, 2, 3 and 4 index position, the value is 98. At this place I want to add some other values and I want to shift all this at the next index value. So what I will do is I will say I will put 4 here, and if I want to put a value at 4 index position, I want to put a value such as say Python at the 4th index. So I can definitely do it using the insert. You can see at the 4th index 98 has been replaced and it is Python. It is actually shifted towards right. So 98 is moved towards right and Python is at place. So that's the difference actually. So this is my L1 and we get all these values in L1. Now we also see some additional functions, such as if you want to reverse anything, so we can use the reverse function, and it will actually see, it will reverse the original list. So my original list is like this, and if I run L1, so it is actually reverse in whatever order it was, whatever sequence it was, so it will reverse the list. Then we have some more functions to discuss, like okay, we have some more functions to discuss. So my list has been now reversed. There is a function called remove. So remove will definitely remove a certain value from a list. Say I want to remove the value k from my list, so it will remove k, and now in the list L1 you will not see k. Now the speciality of remove is it will remove only the first occurrence of k, not all occurrence of k. So it will remove k, and then L1 we have some more functions such as L1 insert, we have seen index, seen extend, count. Copy function is there. We will discuss the copy function in detail for a while. Right now we will just discuss about some other additional functions, reverse, remove, and then we have clear function. So clear definitely clears out my entire list, keeping nothing inside my list and making it as an empty list. So this is how your list functions are there, additional list functions are there. So we have seen max, min, as we cannot apply. So the one that we have seen, if you see the L1, okay, this is my L1. I'll just recreate my L1. So this is my L1. The way we cannot sort this L1 list, in the similar way I cannot have the maximum of L1 as well. So that is quite obvious because it is a mixture of, I cannot get maximum of a mixture of list. A list with a mixture of alphabets and numeric. It is only possible if there is numeric data, because max operation works only for numeric data. So that is the case. So it is the same logic, the one that we discussed in the sort function. It will not allow to sort, basically because we cannot compare alphabets and digits. And we have seen all the functions in detail, and now we will discuss a very important topic, that is copy, shallow copy and deep copy. This is a very important concept in not just in Python programming language. It is a very important with respect to a programming understanding. Okay, if you are writing a program in any programming language. So what is shallow copy and what is deep copy, we are trying to understand. Suppose there is a list called L1. Okay, I'll show you this list L1, and I have created list 2, or list 1 is with value 4, 23, 6 and 9, and I have created a list 2 which is equal to list 1. Okay, now what we have done here, we have assigned the list 1 to list 2. Okay, this means that now if you want to do some modification in list 2, it will also affect in list 1. Okay, now understand one thing, whenever we are reassigning, we are doing what? We are assigning the value of list 1 to list 2. When we are doing this, actually we are also copying the identity of list to each other, which means the whatever is the identity of list 1, that identity will be copied to list 2 as well, and that is why it becomes a single list or same list. So when we do any changes to list 2, the changes will also happen in list 1. Okay. So here what is happening, we are not able to create list 2 as an independent list. Then there is no point of creating two lists. Now it is having the same effect. If I am making changes in list 2, it is going to make changes in list 1. So there is no point in creating a list 2, because automatically list 1 is also getting changed. So this concept is basically not allowing us to create a list, a new list. Okay. So we do it with the help of IDs. We check the IDs of both the lists. We will see this while we are coding. Okay. And then we have another concept where we create list 2 by using list1.copy. I told you we will discuss copy at this time. Now it is the time to discuss copy function. So we are using copy function, and when we use list2 is equal to list1.copy, so whatever changes I am making in list 2, the same changes will not happen in list 1, which means now list 2 is a version of list 1 but a copied version, and both of them will not have the same identity, both have different identity. Okay. So we will discuss this in the code part. So now as we discuss L1, this is my L1. Okay. And L1 has certain set of value. So what I will do is, I will find out first of all ID of L1. Okay. ID of L1. Let's try to see what is the ID of L1. So ID of L1 is something like this, and let's create L2. L2 is equal to L1 I will create. Now L2 is similar to L1, L2 is similar to L1. So if I run it, you can see externally the values are same. Let us see even if internally we have the same values. So we will put ID of L2, and you can see it will have the same ID. So as both the items has same ID, which means both are same unit, like same set of data. So if I use L2, if I want to change a certain value in L2, so if I use L2 and L2 square bracket, if I change the value at 0th position, which is Z, to 100, let's do it. Okay. So now my L2 has changed and the first value has become 100. Now let me see L1. So in L1 also the changes is happening, but we have not made any changes so far. In L1 we have not made any changes. If you see, we are making changes in L2, not in L1, which means L1 is getting changed. So this here we are actually copying there is a deep copy happening. So when we are doing L2 is equal to L1, deeply the identity is also getting copied. So you may create new variables L2 is equal to L1, so which means you are doing nothing, you are not creating a new variable, you are actually you are actually reassigning or creating a new instance of L1, which is nothing but L1 only. So whatever changes you do in L2, it will affect in L1 due to this deep copy concept. Now we will talk about L2, a new concept, that is L1. So see, this is my L1. Now L1 dot copy, if I am using copy, so I am creating copy of L1 and store it in L3. Okay. So ID of L1, as we are aware of, ID of L1 is this. Let's see what is ID of L3. ID of L3 is different, which means L3, let's see if L3 has the same values. So L3 has same values as L1. L1, whatever values are there in L1, the same values are there in L3, but the identities are different. So as the identities are different, if I make changes in L3, say if I want to make changes in the L3, the first value, which is 100, if I make it as say 900 or something, a bigger value, so L3, the changes will happen in L3, but it will not happen in L1. The L1 is as it is, which was 100 at the beginning, the same value is there. So this is a concept of shallow copy. When we use L1 dot copy, we are doing shallow copy, which means we are not copying the identity, we are just copying the values of a list and creating a new list. So we have to make sure that we are whether making shallow copy or deep copy. Shallow copy is a copy where we only copy the values, not the identity. Deep copy is something where we copy only the we copy the values as well as identity, which means if I am doing a deep copy, it will just copy my if I am making any changes in the copied version of data, it will do in the same original version as well. Now what are the problems in shallow copy? So we cannot use shallow copy because if you want to work on nested list, okay, we cannot use shallow copy because it acts like an copy, it stores in same memory location. So here as you can see, there is a nested list, list 1 with certain values, and there is a list 2 with certain other values. Okay, if you want to see the list 1 and list 2, we have printed it. And if I make changes to a certain element of list 2, okay, and I am setting it to 100, for example, for the second list inside the list 1, and we are changing it, the first value of it we are changing it to 100 instead of 12. So if we do it after modification list 1 and list 2, we can see that list 1 and list 2 both are getting a change. So shallow copy actually works if it is a single dimensional list, but not in a multi-dimensional list. To understand it better, we will try to discuss it using Python, and the same happens, the same we will try to see in deep copy. So in deep copy as well, suppose if I am creating a copy of a shallow version of data, for example list 1 is there and I am making a deep copy of list 1 as a list 2, and if we are making changes in 2 data, so we will discuss the concept of copy with respect to deep with respect to a nested list. Now if you want to work on a nested list, we cannot use directly the shallow copy concept here because it acts like an copy and it stores in a same memory location. Okay, so if we are creating list 1 is equal to something which is an which is a nested list, and list 2 is equal to list 1 dot copy. So we are trying to create a shallow copy here, but what happens is if I make changes to any element to this list, the same changes will happen inside my original list as well. For example, we'll try to discuss it in here. So I have a nested list, I'll call it as nested is equal to, and I'll put 2 values. Okay, so the first value, okay, first list has certain values and then second list has, okay, certain set of other values. So now in this nested list, okay, let's apply a concept of shallow copy. So nested list, if I want to index a certain value, say if I want to index this value 8, okay, or this value 2. Now this value 2 is at second index position, okay, second it is in the second list. The nested list has 2 lists, first list and second list, okay. So this value 2 is present inside the second list, so I will put here 0. Now I am in the second list, okay, sorry 0, if I am putting 0, it is in the, I am in the first list. If I want to go on the second list, I have to put 1, so now I am on the second list. So this is my second list. Inside the second list, I want to go on the third element, which is 2. So third element I want to go, so I will put 0, 1, 2, and that's why it will take me to the third element, which is 2. Now this element, as you see, the third element, which is 2, and it will have certain values. So as you can see, this is how we can index on a nested list. I was talking about the copy concept, okay. So if I create nested is equal to nested dot copy, let me create it, and okay, I made a mistake, nested, and I'll call it as nested 2, okay. Nested 2 is equal to nested dot copy. Now nested 2, if you see, this is the value of nested 2. I will compare the IDs of nested as well as nested 2. So you can see the IDs are different, okay. IDs are different here for the nested as well as nested 2 list. It is not the same. Now nested if I'm making changes to a certain element, so I'll make changes in this nested 2 list. Okay, let me make changes to a nested 2 list. So the value was so if I talk about this value, the value was 2. I'm making it as 100. Okay, so I'll make it 100. So nested 2, you can see that value has been changed to 100, which is at the 2, which was earlier 2. I will see that it is happening in nested as well, and even in nested 2. So what is happening here? I am making changes in nested 2 even if I have created nested 2 with the nested.copy concept. I have used copy concept to avoid the problem of deep copy, and still it is kind of giving the same problem. So that is why we need to implement another concept which cannot be worked out here, because I'll tell you, if I talk about the nested list which is here, nested list and nested 2 list. So the external bodies of nested and nested 2 are applying this shallow copy, but the internal list we do not know, no? It is not applying the deep copies. So this is the problem of shallow copy with respect to nested list. It is applicable to the external list but not to the internal list. Whatever changes you do in the external list, it will happen, not to the internal list. So that is why there is a concept called deep copy in nested list. Now let's understand this deep copy concept. So what happens? We create a copy instance of deep copy instance of our list 2 by using the external library called copy. When we do it, it will make or allow us to make the changes in the original list as well as the copied list. So we will see, first of all we have to do what? We have to import this copy, and this is my list 1 or nested 1. Okay, we are using nested, not nested, nested. This is my nested, and I will create nested 3. Okay, nested 3 is equal to copy. So as we are using the copy function, we are importing the copy function, so we have to use the copy instance which is here. Okay, the same variable name we have to use. You can use copy as C also. So if you are using C, then you have to use C here. So I am using C. So C dot, and then we have to call whatever copy method I have to use. I am using deep copy, and we are using deep copy to copy the nested list. Okay, whatever is the value of the nested list, that will get copied in nested 3. And if you see this, nested is this and nested 3 is this. Both are having same value. We will try to compare the IDs of nested and nested 3. So IDs of nested 3. So you have a different IDs. Even when we did a shallow copy using the dot copy concept, we had the different IDs. Here also we are having different different IDs, but the difference between here is, if I use nested, if I change a certain value, if I make the changes like we did here, okay, so we change this value to 100 now. So now we will change it back to say 40 or something. I will change this value to 40. So if I do changes to the nested 3 list, let's see, it will let's see what happened to nested 3. So nested 3 gets changed with 40 value, and let's see what has happened to nested. And nested the original nested list is not getting changed. So if you want to apply the deep copy concept over the nested list, we can definitely use nested. Now here, as we are actually using a nested list, the concept of deep copy actually gets a bit of reversed. So the identity concept now becomes reversed, and now a deeper level copy is happening based on copy concept. So this is how we can copy elements inside a list using the shallow and the deep copy concept. Now we will talk about how we can count the occurrences of an instance. So we have seen this with the help of count function. We have used the count function, how we can count a certain element. If you want to extend a certain list, how we can extend a certain list by other list. We have also seen how to find out the index of a certain element in an list, so that is also possible. We have seen the insert function, how to insert a certain value at a certain position, we have seen it. We have also seen the pop and the remove method, how we can use it. Pop to remove a particular value and show it as an output also, and remove is to kind of remove a particular value at a certain position. So that we have seen using pop and remove in the examples itself. We have also discussed about the reverse operation, how we can do the reverse operation over a list, and we have also seen how we can use this. So list actually is a very interesting data type. It can allow us to work on data. Okay, you can sort sort and reverse a particular data in ascending descending order. Only thing is the elements inside the list has to be of the continuous or the same data type. It should not be different, so it will allow you to sort data as well in a list. So now we will talk about very important concept, that is slicing in a list. So list actually is a very interesting data type. It has it is a continuous data type. It is a sequential arrangement of data. So it will always have a starting point and it will have a stopping point. And step is something which allows us to tell us, okay, how much time, how much step size I should take. Like, should I skip something or should I go with the same continuous values? So that is a set of way by which we can slice a list. We have seen the slicing concept. We will now be discussing in detail about slicing with respect to a nested list as well as a normal list. Okay, so we have seen the positive and negative indexes concept also. We will apply the same with respect to a list data type. So let's discuss about a nested list which we have here in front of us. So this is our nested list. Now we are talking about indexing or slicing a list. If I use slicing of this list, so suppose I have one more element inside my list. So this is my list and this is my list, and I will add one more element inside my list, and I'll just change so values inside the list. So I'll make it as 11, 41, 12, 41, 18, 92. I'll make it as 10, 54. Okay, so this is my new nested list. Let me run it, and this is my nested list. Okay, now nested list, we have discussed the way we can index a normal list. It is similar to what we have done, and it is similar to one which we have done using string data type. So if you talk about L1 as a list, so L1 is a normal list of that I have. Okay, so for a normal list, how to do the indexing? It's quite easy. Like, you can use the same string approach. If you want the first element, L1 square bracket 0, it will give you the first element. If you want the first 3, you can put 3, you will get the first 3. If you want the last value, you can use -1. If you want to reverse the entire list, you can reverse it like this. So we have already discussed this concept of kind of how we can create a list using or how we can slice a list, slice down a list. It is similar to what we have done in string. Okay, so no differences. We can also say, if you want to get all the values like this. Okay, sorry, L1. Okay, so it is giving me all the elements inside the list, as we can see, from 100 till all the values except the last value, which is 1. So last has to be 1. It is leaving the last value in the list, and it is returning all the elements. So it is returning from here till here all the element except the last element of a list. So this is how we can do. It is similar to what we have used in string. Now we will be talking about the detail on the nested list part and how we can use it, because most of the data structures are usually in a form of tabular structure, and that is why it is essential to understand how we can loop over, or how we can traverse over this nested list. So this is my nested list with certain values, list 1, list 2 and list 3 and list 4. And if I talk about this list traversal, so my nested list is a component of multiple lists. where each element is a list. If I talk about 0, so it will throw me this list. Okay, so I'll not run it, I will run it here. Okay, so if I'm talking about 0, it is the first list. If I put about 1, it will give me the second list. If I talk about 0 is to 3, it will give me the first 3 lists, 0, 1 and 2, first 3 lists. If I talk about 0 or square bracket minus 1, which means it is giving me all the lists in the reverse. Now the concept what we are talking about here is how to index over an element. So if I want to index over a certain element in my list, so if I am talking about the first element of this list, or if I want to see this second the element 4, okay, or say if I want to get this element 100, so if I want this element, how I can do it? Okay, so I can use nested square bracket. Now this element 100 is present in at which index position? It is present at index 0th list and first list. So I have to first get to this list. How to extract this main list? Okay, this second list that I am interested in. So for that I can put here 1. So it is giving me the list 8, 9, 100 and 5. Now inside this list I want the element 100. So element 100 is at 100th position. Okay, sorry, it is at the 0th second position, 0, 1 and 2. So if you see 0, 1 and 2, so if I go put 2 here, it is going to give me 100. So if you want to get a value within a nested list, this is what you can do and get the values from a list. If I put like this 1 is to, it is giving me all the elements in the list at the second position. For example, the list 1, this is the 0th list, it will not take this list, it will take this list into consideration. So you can see it is giving all the elements starting from the first. Okay, first list it is giving 18, 92, 10 and 54. So it is going to give me the last list because I have selected this list. In this it is going to select me, it is giving me this list because this is the last element. I am putting 2 over here, let me put 0, and it is giving me the list 8, 19, 8, 905. As I have put 1 is 2, so 1 is 2 if I am putting, it is giving me this list. Okay, so if I am putting 1 is 2, so these are the values I am getting, and if I want the last list, I will put 0, 1, 2, I will put 2, it will give me the last list. If I want second list, I will put square bracket 1 and it will give me the second list. If I put 0, it will give me the third list, because now my list is sub list is this is my nested 1 is to 1 is to means this is my sub list that we am talking about. So if this is my area of interest, this is my list, so this becomes 0, this becomes 1 and this becomes 2. So this is how the concept of indexing revolves around a nested list. So we have seen the positive indexing, negative indexing in a list. If you want to find out a list value, suppose this is a list, and in this list if you want to find out, or if you want to use negative indexes, so if you want all values from -1 to 0 in a reverse order, or if you want to get all the values except the last value, so it will give you all the values except the last value. You can use negative indexes also, like if you want all the values from -3 position to -1 position, so that also is possible, like -3 position is this much, -1 position is this one, so it is giving this value. So basically it ignores the last value whatever you are mentioning as per the Python general syntax, so it ignores the last syntax or last value. So we have seen what is a negative index and how we can use it in a list. Here also we have discussed about how we can index with respect to different values. So we have covered kind of all the topics revolving around list and all the function, basically how a list can be worked upon, the list inbuilt function as well as some external functions which can help us with list. Now we will talk about tuple as a data type or a collection data object. Tuple is similar to list. It can also store different set of information. It is heterogeneous in nature, which means all different types of data types I can store into a tuple, like boolean, integer, float, string. It is a container object, which means it again contains multiple attributes or objects together. We can create duplicates of tuples, so that is also allowed, but tuple objects are not mutable, which means these are immutable. If you have created a tuple and if you want to change a particular tuple, it is not possible at all. So tuple is a data type which is rigid, which cannot allow change. Tuples usually are created with the help of parentheses and are separated with the help of comma. So elements inside a tuple are separated with the help of a comma. Now there are certain things that we need to understand about tuples, like what kind of operations it supports. It supports in and not in membership operators. It supports concatenation. It supports min, max and length operations, which helps us to find out the minimum, maximum and the size of the tuple, and indexing and slicing. So we can do indexing and slicing of a tuple. So let's see how a tuple is created. So a tuple is created by using round bracket. Instead of square bracket in list, we are just replacing it with the round brackets, and each element is separated by comma. We can see a tuple over here which has certain values like tea, coffee, sugar, noodles and bread, and then 2.5, 3.2. This is to see that we can have multiple data types in a single tuple. Tuple objects are created by round brackets. Okay, so you can also choose not to use this round bracket. Okay, even if you don't use round bracket and you directly put some values like tea, coffee, sugar, noodles and everything, by default it is a tuple, and it can be stored into items, like whatever variable that you are creating, it will get stored into a variable as a tuple. Now understanding the principles of sorting elements in a tuple, we can use we do not have an inbuilt tuple function of sort, because as you know, sort, if I use the dot sort function over a list, the dot sort function over a list allows to sort the data in the list and it makes changes to the list. So as list is a data type which is mutable in nature, it allows to make the changes. Tuple is not, therefore dot sort function is not there, there is no scope of it. That's why we have to use sorted function. Sorted function sorts a tuples and returns a sorted list as an output, but it doesn't make changes to the original tuple. So we have seen the tuple with respect to different operations. Now we will talk about creating or repeating the elements of a tuple. Suppose there is a tuple with values pizza and cola, as you can see on the screen, and if we do order received or the multiply the tuple with 2, it is kind of creating a new tuple with the same set of values, repeating the values inside the original tuple. You can concatenate a two tuples together also, which means there is a tuple 1 and tuple 2. You can just use the plus operator to concatenate. We cannot extend a tuple like we do in list. It is not possible in tuple. So let's try to work out all this over your Python code. Let's understand tuple in detail. It's a very interesting and important data type. So let me create a tuple. As I told you, tup1 will be my tuple, and I'm creating a tuple without using a round bracket. Okay, I'm creating a tuple without using a round bracket, and you can see it is creating tup1 and it is a tuple. You can simply use round bracket as well. Okay, both the syntax are allowable. You can access the element as we do in the Python. What is the element at the 0th index, what is the element if I want element from 0 to 2, if I want element 0 to 4 or 5, it will give me all set of values that I want to get from it. But if I try to do item assignment, okay, tuple square bracket 0, that is fine, it is returning that value. But if I want to change that value to 90, it will not allow. because tuple is not iterable at all. Sorry, tuple, because tuple is not mutable, it will not allow you to change. It is an iterable, it allows you to iterate, okay. And tuple 1 is our tuple. In tuple, if I want to create a tuple like this, it is allowing me with or without round brackets. And as I told you, like if I want to sort a tuple, okay, now if I use dot, and you can see there are only two functions, inbuilt function in tuple, that is count and index. Count will tell me, okay, how many times a particular number is repeating, say 8, so it is telling only once, and it can return me index of a particular value. So what is the index of a certain value? So suppose I want to find out the index of number 65. So index of number 65 is 4. Apart from that, tuple doesn't have its own function. There is no extra additional functions in tuple. Yeah, but we can use additional external functions to work on any tuple. For example, you want to sort a function, sort a tuple, you can use sorted of tuple 1, and it will give you sorted version of the tuple 1, but as a list, as an output. If you see the type of this data, it is a list as an output. You can simply see it as an output also. So if you are sorting a tuple, it is possible, you can sort it, but the output that you will be getting is a list, not a tuple. Original tuple arrangement also cannot be changed. So the way the data has been arranged in a tuple, you cannot change the arrangement as well in a tuple. Now suppose there is a tuple 2 with certain values, say p and 1, okay, there is a value called p and 1. I can create a new tuple 2 into say 3 times, and it will create a new list of values, okay. Sorry, this is a list actually, that's not a tuple. Let me create this as a tuple. Now if I am using tuple 2 is equal to p comma 1, so if I multiply it by 3, I am creating a tuple, bigger tuple with p1 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 values, which means the values are getting repeated. Now we will also discuss, we have discussed about this tuple multiplication and concatenation of tuple. So say this is a tuple 1 that I have, this is a tuple 2, okay. So if I use tuple 1 plus tuple 2, it is fine, it will not do any problem, it will not give any problem, because as long as I am not making any changes to my original tuple, it is fine. Original tuple is not changing, original tuple is as it is, the value is still 1, you can see it is there. All I am doing is I am just applying a concatenation operation and showing it. I can save it into an external tuple 3. You can save it, you can also reassign it to tuple 1, that is also possible, but tuple 1 is not getting changed if you run just tuple 1 plus tuple 2, tuple 1 is as it is not changed. So that is the operation in tuple. Then we will talk about some operations such as in operator we can use, not in operator we can use. For example, this tuple 1 is there, and I want to see that if a number is present inside it or not. So 22 in tuple 1, it will give me true because the number 22 is present inside tuple 1. If I use not in, so it will say that false because it is there, but I am saying not in, still my argument is wrong, that's why it is false. Then we will talk about iterating over the elements of a tuple. So tuple allows you to iterate over the elements, so that is the best part of tuple. So for I in tuple 1, it is the same way that we do in list. So if I print I, it is allowing me to print I over the element. So tuple allows me to kind of iterate over it, all the elements over the tuple. Then we can also use functions such as length of tuple. So length of tuple 1, it gives me 9, so this is the length of tuple 1. And these are some basic operations over tuple. We can find out maximum, we can find out minimum, all different operation we can find out, or we can do it on a tuple. So max of tup 1, min of tup 2. So these are external external functions actually, max and min. These are not the inbuilt, these are inbuilt function only of Python, but not for tuple class. It is not belonging to tuple class. Okay, so we can find out the maximum and minimum, and if it is a mixed data type, we cannot find out the maximum value. For example, if it is a mix of tuple 1, okay, tuple 1 plus tuple 2, if I do, so it will not allow, because integer and string cannot be compared, that is not possible. Same does for tuple, and same does for tuple. And if I want to delete a particular element of a tuple, for example, delete of tup1 square bracket 0, it will not allow, because as we discussed, tuple elements cannot be mutable, it cannot be changed, so we cannot delete it. So we have discussed about slicing, how we can slice in tuple. The same way we have used the slicing in a list, we are going to use the slicing in tuple as well. So you can see the same demonstration, we have discussed it at the beginning itself, how we can slice over the elements of a tuple. And now we'll move on. Now we will move to the another set of collectional data or element which will allow us to store the data in a very systematic way, that is dictionary. Dictionary is a data type which is a derived data type, and it is very useful to store data in a form of key and value. So dictionary allows us to store the data in element wise in a form of key and value, and we can use curly brackets to create a dictionary, and we can also use square bracket to index the dictionary based on a particular key value. Dictionary are mutable, which means you can change it, and these are unordered. Okay, so we allow dictionary to store the data in a form of key and value. The syntax of a dictionary looks like this. So the way it looks like, the first part is a key, then we have colons, and then we have value. These are the two components of a dictionary, key 2 and values. So key can be anything, value can be anything, but if you want to access a particular value, you have to use key as that particular element to get extracted. So here, as you can see, there is a key for there is a dictionary being created. The key of this dictionary is into machine learning, and the value is 20. Big data Hadoop, the value is 25. Spark, the definitive guide, the value is 15, and data science using Python, the value is 12. So this is a dictionary which stores the information in the form of key and value pair. Let's try to discuss about this dictionary in detail. How we can work over a dictionary data type. Let's first go through all the necessary elements of this dictionary data type. So we can also use square bracket indexing to find out or extract a certain value of a dictionary based on the key. We can delete a certain element from a dictionary by using the delete keyword, and we can use a kind of we can use okay. So let's try to understand the dictionary with respect to this function. Okay, we will try to use it in a Python. Let's understand the dictionary data type, then we will discuss about the further major topics inside the dictionary. Now let's understand what is a dictionary, how to create a dictionary. So I have a dictionary D1 with created with the help of okay, certain value. So I am putting key as A, and the value I am putting is say 200. Okay, this is my first value. So 200 is my value, and the key or the index is A. Key basically acts as an index. Okay, and I'll put the second key as B, and the index value I'm putting is 789. The third index as C, and the value that I'm putting is 213. And this is my normal dictionary, and if I run this, it will show me the data as it is, as I am declaring it. The way I have declared it, the same way I am getting the dictionary. Okay, it is not something which is big or something. So if I talk about D, and D has certain values to, so D, the value of a dictionary can be a list like this. So my dictionary also can store it can, the value can be anything, any number, any list, any tuple, anything can be a value. Okay. If I want to extract a certain value of my dictionary, for example, if I want D1, if I want to extract what is the key, value for B index, so I cannot use, if I am using 0, see it is not, it is saying there is nothing, there is no key called as 0, there is no 0 key. So here it cannot use the same indexing procedure that we used in the previous data structures like list, tuple and string. We cannot use 0 or we cannot use like this, it is not possible. Dictionaries are not hashable, so we have to mention what is the index that we are looking for. We are looking for A, so we have to mention, say A, what is the value of A, it is 200. If I want from A to C, I want all the values, I have to mention A to C like this, then only, okay, it doesn't support. If you want to index a certain values of a dictionary, D of A is the right way of indexing. We get 200 as a value, and we can index or any element. Say if I want the D last element, I can get it like this. So this is the method of getting values in a dictionary. Okay, so this is how we can do it. Now dictionary has certain functions also. Let's try to understand those functions. D1 dot, and you can see there are some functions like items, keys, pop, update, and all different set of functions. Dictionary has all these forms of functions. I will discuss about items first. If I use items, it is going to give me all the elements as a list of tuples. So what is this tuples? The tuples are basically the key and value pair. So key A, the value is 200, key B, the value is 789. So D1 dot items will give me key value pairs in a form of tuple in a list. Then if I only want say the values of a dictionary, so I can use D1 dot values, and it will give me only the values. So values are 200, 789, 213 and this list. If I want only the keys, so D1 dot keys can definitely help me to get only the keys. So A, B, C and D, these are keys of a dictionary D1. Dictionary also allows us to change a values also as discussed. So suppose the last element of dictionary is say this is the last element, which is like a list actually, and this is my original dictionary D1. I can change, I can do item assignment for the last element. So I can just change the value here also, like I can put 321, and if I do it, so last value is not a list now, it is a number. Okay, so we can change values of a dictionary as well like this. So it is a very interesting data type, and we can also delete a particular value. So if I suppose want to delete D1 square bracket D, so that is also fine, it allows me to delete, and you can see the D value or the D key value pair is gone completely. So we have this function D1 dot pop also is there, which allows us to okay, D1 dot pop, I'll put C over here, and it is popping out the last value, which is 213, and if I run D1, so see A and B is there, only the last value is not there. So these are certain functions in dictionary that we can definitely use in our programs. Now we have learned about deleting a particular element. Now suppose I am creating a string variable like can you, can I, can as a canner, canon, and all these different details are there in my string. It is a tongue twister actually, and I want to count how many times a particular word has come inside this tongue twister. So for word in twister dot split, what I am doing is, if word not in word count, so word count word is equal to 1, which means what we are doing is we are increasing the count, we are assigning the count of the word is equal to 1, else word count of word is equal to plus 1 or plus 1. So basically what we are doing here is we try to find out the occurrences of different words in this word count dictionary. We are creating a word count dictionary, and this word count dictionary will count how many words are there inside this particular list, okay, or inside this string. So first we create a string, then we create a empty dictionary. After empty dictionary, we will iterate over the elements inside this twister element or twister string, and we see that if word is not found, so word count will remain 1 only, okay. Else if if this condition is not true, if this condition is not true, which means word is not found, which is not true. If word is found, then word count will become word count plus 1, and by default there is no word count. As we can see, the word count element value is nothing, okay. So let's try to understand this. Here we will try to create a program in Python as well. I need to copy this string. S is equal to can you can a can as a canner, can you can a can as a canner, can you can, like this. I have just written a dictionary. I will create an empty dictionary D2 with certain values, like nothing is there inside this dictionary. And now what I will do is for I, okay, for word in s dot split. Now whenever I am using split, as we know that when we use split, it will give me a list of words, okay. And if this D2 square bracket word is not in, okay, so as we are trying to find out if a particular word, so sorry, if a word is not, okay, is not in D2 square bracket word, okay, or when we talk about D2, if the word is not present in the word count, okay. So word count is a dictionary D2. If the word is not present in word count or this dictionary D2, we will put the D2 square bracket word is equal to 1, okay. D2 square bracket word equal to 1, else we will increment it. Okay, now let's see what we get here. So D2 is an dictionary which will be storing certain values. So it will first it will store can, how many times can is returning, how many times u is there, how many times a is there, how many times, like that. So there is an important thing to understand about a dictionary. Dictionary does not have does not allow you to create multiple keys. For example, I have can as a key. I cannot create a new can key. Keys are unique in nature in a dictionary. I can have multiple values, but I cannot have the same key, okay. So in a dictionary, key is not, it is not possible to create a multiple keys with the same name, okay, and that's what we are trying to understand here. So here I have can, you can, this is my string, and I am doing what, I am iterating over each and every word in my string. And if the word is not in D2, which means if D2 is empty, okay, if this word is not present, so what I am going to do is D2 square bracket word is equal to 1, which means I am counting that word as 1, okay, because it is not there, and now I have found that word, therefore the count is equal to 1. Now in the second iteration, for example, if here if I talk about the first string, so can is not there, so D2 can is equal to 1 it will become. Now D2 has new dictionary, new value or new key value, that is can is equal to 1. Now when I iterate over the second element, that is u, so the second element u, this is also not inside D2, that's why u is also assigned the value 1. Now the third element can, so can, it will check if can is present inside D2, so can is present already and it has the value 1, that's why this if block will not get executed, else will get executed. That's why D2 of can is equal to D2 of can plus 1. So D2 of can right now is 1, so 1 plus 1 will become 2, and it will do it for A. So A is not there, so it will create A as 1, and likewise it will print. If you want to see the progress, so we can print our dictionary D2 here, and this is how it happens. So initially can was the only first word that was found, so can got assigned as 1, then u was assigned, so u is getting the value 1, and then can, again we encountered can, so can, the count of can increase by 1 because we have not entered this if block, we entered this else block. And similarly u remained 1, then we on the next iteration we encountered A, and A got added here. In the next iteration we got can, and again can incremented to 3 because we didn't enter this if block, we enter this else block. So according to the else block, the value of can has to be incremented by 1 unit, and like this we at the end we are getting a list with how many number of words are getting repeated multiple times. So can is the word which is repeated most of the time in this dictionary. Now we are trying to consider this word count program. So we created a string and word count. So for word in twister dot split, word count square bracket word plus 1. If we directly do it, it is throwing an error because the key is not initialized and we are trying to add 1 to an uninitialized key. So if you do not use this concept which we have used earlier, where we are creating word count of word is equal to 1, if we are not doing this, this will not be implemented, okay, because there is no key at all. First of all, we have, if we are encountering any word even at once, so we have to assign that word count that particular key as value 1, okay. So that key is defined with value 1, and in the next iteration if we again encounter the same word, then only we are incrementing, because in the first iteration when they encounter it for first time, we created a key value pair, and in the second if we encountered it second time, we are just incrementing the count of that word. So this is how this program will actually function using dictionary. Now let us try to understand a default dictionary. In order to avoid the error for uninitialized values, as we use something called as default dict. Now for default dict, we have to import the default dict from collections module, initialize the dictionary object with default dict, and we passed integer to the default dict, and when the dictionary object encounters a key that was not seen before, it initializes the key with a value returned by integer. So here in this case it can use 0 as the key. So we are using a default dictionary here. So for example, we import a default dict from collections module, and we can use the collection modules directly, and right now as we are using this default dict which is different from the original dict, we can directly use the same function over here. So what we are doing is we do not have to use that if condition, we directly use it, okay, directly use the default dict concept. So this word count created a default dict of integer type, and now see, this is not a Python specific dictionary. It is a dictionary which is coming from the collections module, and we are using default dict function to kind of create this function. So it is not an inbuilt kind of functionality of Python, it is an additional element that we are talking about. So what we will do here is word count is equal to default dict of integer, and for word in twister dot split, now here I am not mentioning any other condition, I am just mentioning word count of word is equal to word count of word plus 1, which means it will, if in case I am not encountering that word, or I have encountered it for first time, it will take care of that situation and it will assign it as value 0 or 1. So this is how this particular function actually works out. So we will try to create it using Python. So it is same, but the problem is we are not going to use this, we will directly use okay, and we will try to see the progress for it. From collections we will import dict tool, it is dict tool only, right? Default dict, sorry, it is default dict, and d2 will not be now d2, it will be default dict data type of integer type. So we have to specify which type of data it is, default dict integer type, in order to work on it. Now let's see the progress. Okay, so now I do not have to myself create a variable to assign it as 1. So by default it will work in the same way, but here the problem which I was facing earlier, where I was supposed to check if it was present or not, that I do not have to do. Default dict will directly create a default value and assume that that particular dictionary is there inside this iterable. So we do not face any error as such as we are facing here if I don't use this if condition. Now there are certain operations that we can use over a dictionary, like length of dictionary, type of dictionary. We can also use clear, we can also use copy. So we can create a copy of our dictionary as well. So we have seen this, some of the function like key and value. We can also find length of dictionary, say d2. So length of dictionary d2 is 5. We can clear d2 dot clear. There are a lot of different functions. You can see clear, copy, from keys. All different functions are there. Keys and values we have already declared, seen. So d2 is right now with no other value. Okay, we'll talk about d1 as well. So d1 is my dictionary, d1 dot, if I use copy, clear, from keys, so it will have the same functionality both from default dict as well as this dict. It will have the same functionality as we are having over our function. So we have already seen the copy function with respect to the list, so we can use that copy function as well. So d2 is equal to d1 dot copy, if I use it, so d2 will now become the same value which d1 is having. So d1 doesn't have any value, so d2 is also not having any value. I will create a d2 here, I will create a d1. So this is our d1, and if I create d1 here, so d2 will also have the same value, but d1 dot if I want to type or find out the index of d1, so id of d1 is this, and I can also see the id of d2, it is not the same. This one important thing that I was talking about dictionary d, like any dictionary is, so dictionary as I told you, like if d1 a is equal to 200, okay, so if I want to add a new element in my dictionary, I can put, say I want to add element e, I can put e, d1 square bracket e, I can add a new element e and it will be say 90 or something. So a new element can be added, okay. d1 also actually so this is the method of adding a new element in a dictionary. What I was saying is say this is my dictionary d1, and in this d1 dictionary if I want to add a new element a, okay, so if I use a is equal to say 211, it will not create a new element a, it will definitely change my original a. So dictionary cannot have a unique, or it cannot have a new key with the same name. So the keys of dictionaries are unique in nature. So we have seen the keys function, values function and items function, and we can also use get value, get function to get a certain value based on the key. it is similar to the one that we have used. Okay, so there is a dictionary called as sanitizer, hanger set, and class. So if we use get sanitizer, it will return me the value of sanitizer. If I'm using get wallets, so wallets is not there, so it will return none. So it is quite obvious wherever we do not see any value in a dictionary. So d1 dot get is the function that we are talking about. So get basically requires an argument, that is say a. So if I'm using d1 dot get a, it will give me certain value. If I'm putting o, so there is no key called as o, so it will return none. It is not going to return anything. So that is the difference that we can see in a dictionary. Now we can see a dictionary. We can also use a set default if in case a particular value is not there. For example, wallets is not here, so we can use set default functions to kind of work on it. So it will add a new value wallets with value 4.5. And then we have from keys. So for example, I have a dictionary, and if I want to use from keys, we can use from keys as well. We'll try to understand from keys. First, let us use get default or set default, the function that we have just seen. So if in case I do not have the value o, okay, so d1 dot, we also have a function called set default, and in set default I can mention, okay, there is no, suppose there is no p, so please get some value. So if p is not there, let us put some value, say p has some turn value 890 or 2 or something like that. So if I talk about d1, now I have p with value 8902. Okay, so this is a key feature of dictionary, and we can do it in dictionary as well. Now we will talk about the important dictionary construct, that is from key. Now suppose there is a tuple order ID, customer ID, and amount with values order ID, customer ID, and amount. Now if I use dict1 is equal to dict dot from keys tuple, so what it will do is it will create d1, okay, d1 from tuple, whatever is a tuple, from that it will create a new dictionary dict1, and it will not have any values as such. Okay, okay, so if I want to create a dictionary from a particular tuple, list, or anything, okay, so that I can do. Okay, so if I use a tuple is equal to say 100, or tuple is equal to 10 comma 70 comma 67, so this is my tuple. And if I use dict dot, and you can see from keys is there. If I'm using from keys and I want to create, so I want to create a new dictionary, d2 is equal to from keys of tuple tup. So d2 gets created, but there is no value assigned. If I want to assign a value, what I can do, I can simply pass in a value, say 0 or 9, and d2 will now be having values 999 across. So this is the method of creating dictionary from some other data types. Now we will talk about dictionary of a certain data, and how we can work on it. So here we have a dictionary with certain values, glass, hanger set, sanitizer, and wallets as the keys, and certain values assigned to it. And if I want to change a particular value, we can do it in dictionary. We have already seen how we can do. Similarly, we can do it for we can delete the elements of a dictionary. We have already seen how we can delete it. Then we can also see that what is a particular dictionary. So we can also create a duplicate dictionary from an original dictionary. Okay, so here we have items purchased as the original dictionary, and we can print the original dictionary, and Here items, dictionary item names is equal to whatever is the name of the dictionary items, and selling price is equal to whatever is the values. So now we can also create a new dictionary from our existing dictionary. Let's understand how this works. So I'll explain it with the help of a tuple. So I'll create a list of tuples like this. So tuples value 1 comma 3, and or let me put the value as a comma 9, and n comma 8. Suppose this is a list that I have, L3 is equal to, and I have a list, and based on this list I want to create a dictionary. So I can create a dictionary if I have tuples inside it. So let's do dict of L3, let's try it out. So you can see it is creating a list of it is creating a dictionary based on list of values. So we can definitely create a dictionary based on list of values if in case you have the set of values. So I am having list 1 and say L2, okay, like this. These are two lists that I am having. What I will do is, so what is the length of list 1? I will do length of list 1, it is 15. So I'll do what? I'll pop out dot pop. I'll pop out any value from this list, and now this is my list L1, okay, with certain set of values. What I will do is I will divide it into two halves. So the length of this list, if I divide it, it has 14 elements. So I will create the first half as keys and second half as values. So, or we can do what? I will create a list of range of values 0 to 1 to 15. So this list is the values from 1 to 14 as numbers. Now I will store it as a numbers is equal to, and list I already have. So numbers actually have values from 1 to 14, and list 1 has values, again these are 14 items into it. So I can create a dictionary using this the combination of numbers and lists. So I will do what? I will zip out numbers and L1. So if I do it, it will create a dictionary based on numbers as keys and values as the value in the L1 list. Okay, so you can combine multiple things together, like you can create a dictionary using list, you can create a dictionary using the range function as well. So this is how we can definitely work on dictionaries. Now we will discuss about a unique programming construct that we can see only in Python, that is list comprehension. So list comprehension provides a concise way to write your code or create a list from another iterable. This consists of brackets which contains a certain set of expression in a form of for loop or something, and based on the output that is returned by that for loop, that gets stored inside the list. So we will see how exactly this comprehension works. It is possible to use conditions and loops in a list comprehension, and the output is always a list in a list comprehension. So here is a general syntax. So you can see the output is something that we have to put here, and for I is an variable in the list if a particular condition is met. Okay, we are creating a comprehension based on a certain iterable. Here the iterable that we are considering is a list. So we are taking some element from a list which is an iterable, and if that particular condition satisfies inside this list, these values are getting stored inside this output. Okay, so let's consider an example here. We are storing the cube expression, or the power 3 power to the 3 of any values inside 1 2 3 4 if that value is greater than 2 only. Okay, so we are this is our list. Inside the list we are just storing I to the power 3 only if the value is greater than 2, and we are iterating for values from 1 to 4 list. So in this list, if there is any value which is greater than 4, we are going to store it. Okay, so let's try to use it to create a dictionary, sorry, list, using a list comprehension. An output expression, it consists of three components, that is an output expression, an iterable, and a conditional expression. So condition to condition express over this data. So it is similar to the one that we are using a for loop. For example, I am using a for loop. I am having a series number, and I am just wanting to create the power of, like, I'm going to create a serial number of 1 to 10. The power is 2. Okay, so basically I am creating squares of number using a normal for loop. So if I am using a for loop, I have to write or create a variable series number is equal to square bracket. I have to iterate from I is equal to range 1 to 11, and then series num dot append. I have to use the append function again for adding I square. So I am adding I square in that series num, which is an empty list. So this is fine, but it actually takes some space, as well as it also requires some time complexity with the help of this append function we are using, this for loop we are using. So we need some time, complexity is also high in such cases. So list comprehension definitely helps us to create the same list, but without using this append function and all different functions or range, iteration over a for loop. Like a normal for loop we are using here as well, but we do not have to use that append and all for this list comprehension creation. So let's try to understand how we can create this list by using this list comprehension. So I have a list L1. If you see, this is our list L1, and I want to create an L2 list, okay, from L1 using this list comprehension. So if I'm using list comprehension, for example, I'll just use without a list comprehension. So initially L2 is an empty list, and let me create, so I'm creating L2 to store only alphabetical values. Okay, so if the value is alphabetical, I will store inside the L2, otherwise I will not store it. Okay, so for I in L1, okay, if I dot is alpha, okay, or if type of I is equal to string, if the value that I am passing, okay, if type of I is equal to string, okay, so I will append that to L2 dot append I. So I'm appending value in this list if it is string in nature. So if I see this L2, initially it was empty, and now I have L2 with only string values. Okay, so this I have done with the help of a normal for loop. I have to use the append function, I have to write multiple queries. No doubt it is easy, but you can do it in a very efficient way using this list comprehension. How we can do it? I can create a list, and I am putting in I into it for so I am iterating over for I in this iterable or in a value L1 if a particular condition. So if type of I is equal to string, so I am storing I am storing the values from L1, and I'll create L3. Okay, so L3 is a list which stores I if and what is I is starting from I is all the elements inside L1. So it stores I for all the elements in L1 if that particular I element is of string data type. So we'll run it, and you can see it is giving the same output as T2. Okay, but here we are writing only one line of code and our code is done, but here we have to write like multiple lines, and the same effort like it has to be put, but the logic and everything remains same for both of the cases. So we can see we can also store a square of elements in a particular data. For example, in our case we will not you can have a look at these expressions as well, where we are having a certain list and we are iterating over each element in the list and taking squares of the values. Here also we are doing the same thing, but here we are doing it in a different like in a list comprehension method. But we can do what, we can also say if I want to store the squares of number, okay, from L1. So I have L1 and I want all the elements from L1 which are number, I want to take square of all the numbers from L1. So I can do it like this. If I am using this normal method, I can do it and I can take square of I. If I is integer, I can take integer over here, and now L2 will have all the integer values. L2 will have all the integer values and the square of it, like square of all integer values inside the L1 list. We can do it the same way. All we have to do is just we have to put the condition as int here, and I can just simply take I square, not I, to I to the power 2, and we are getting the same output. Okay. Now the best part of list comprehension is we can extract a certain set of values. For example, if we want to extract only the first letter of all the elements inside a names. For example, I have the names in a list. For example, so these are certain names that I have in my list. X is equal to list, and what if I want to extract only the first letters of all this list? So we can do it with the help of a normal for loop, or we can do it with the help of our list comprehension. So if I want only the first letters, I can create first letters like this, and I am creating a list comprehension where I square bracket 0 I am taking for I in so I in this X. Okay, if I do it, I'll get first letters like this, and this is my first letters. What if I want only if I want vowels? So if I in vowels A, E, I, O, U, let's see if it is working. So it is returning 0 because I am not checking for I. I should not check for I if I am using I square bracket 0. So it is returning the names which are only starting with a vowel. So you can see if I add one more name like this, and see it will return all the names which are starting from vowel. If I use not in, and then it will give me all the names which are not starting with vowels. So this is the benefit of using this list comprehension. It allows you the flexibility of writing a code with expression, and also minimize the efforts in writing the code. Now suppose I have we have seen this program extracting all the elements, all the numbers from the string using string comprehension or list comprehension. So we can extract. So for example, I have this list of I have a text over here. I want to extract only some numbers from it. So Python is special in 2024, but it is not as good, or but it is 20 times faster than calculators. So I am just trying to put some random text with some numbers. So this is my string, and now I want to extract only the values like numerical values from this list. Okay, so it's very easy. We have done it like the same expression, lambda expression we are going to use, the one that we have used here. Let me just, yeah, this is this one. So I will just use the same expression and I'll call it as number. I'm just extracting numbers from my list. so I for I in L, if number I is equal to integer, okay, I'm using integer, type of I is equal to integer, okay. I don't think this is going to work out, like I'll just keep it park for now. So for I in L1, not L1 I'm going to use, I'm using text dot split, okay. So here now I'm just changing the strategy, because this is a text, I will split it. So when I split it, it will create a list of words, okay. So I basically are the words inside this text. So words, so I'll call it as words only, words for words in text dot split if type of word is equal to int. So now see, type of word is always going to be string only, because all words are going to be string, even this 2024 is going to be string. So I cannot use type of word. Yes, I will do one thing, I will use word dot is alpha or is numeric, okay. We have this alphanumeric, alpha or is numeric, so I'll use is numeric. So word dot is numeric, which means if the word that I'm searching inside this text dot split, if it is numeric, then I will add it into the numbers. Let's see the change. So word is not defined, okay. So I'll use words, and here also words. Now it is clear. So it is able to extract only the words from my textual information, that is text. So this is how we can iterate over a list and get only the numerical values or the numbers from this list. And if I want to store this as a number, what I have to do is I have to just put integer in front of this integer of words, and now I have exactly extracted numbers, not the values which are numbers. So the type of this data is also number now. So this is how we can definitely use list comprehension to get more precise data and use for data extraction in a textual file. Now we have already seen how to extract vowels, so that we will skip it for now. You can see this program, and here we can see certain statements. So using nested conditional statement and list comprehension. Now let's understand what is nested conditional statement. So here we have products is equal to apparel, crockeries, cosmetics, beverages and detergents, and discount is equal to, we are creating a discount. So discount should be 10 if P is equal to apparels, else 15 if P is equal to crockeries, else 20 for P in products, okay. So if P basically represents products inside this products list, and if P is equal to apparels, we will give the discount as 10, and else we will give the 15 if P is equal to crockeries, and else if nothing satisfies, we will give the kind of discount as 20. So let's try it out and see how exactly this works. So let us create, so I will take this only and I will change the names, crockery, shirt, t-shirt, watches. I'll just give some different names, and cleaners or something. I'm just giving random names. So I'll do one thing, I'll just repeat crockery over here, okay, t-shirt and shirt over here, okay. So just to make it more, I think here also we have the same thing, kind of things which are repeating. So we will start with this conditional statement. So first thing, I'm just creating discount, okay. Discount is equal to square bracket for val in x, okay, and I want to return 10 if a certain value, if val is equal to, if val, so here we are using single double equal to for comparison. So val equal to, and if I'm using shirt, okay, for shirt I'm giving discount, okay, I don't have to use this, I'm using, okay, if val is equal to shirt, I'm using 10, else if val equal to say t-shirt or crockery, if it is crockery, okay, so first condition is if the value is equal to if the value that we are checking, if it is 10, so if it is apples we are assigning 10, else we will assign 15 if value is equal to crockery, else we will assign 20. Okay, so else we will assign say I'll take 5% if the value is equal to crockery, or else if none of the condition matches I will assign 40 or something just to see. And now if you run it, discount, and you can see wherever crockery is there, for crockery 5 discount is there, and wherever you see shirt is there, the discount is 10. There is one shirt here and there is one shirt here. So it is not actually if value. Okay, let's see what happened. So here we have used else 40. Okay, so for value in x, and let me run it again. Okay, so let's try to iterate over it. So initially the value in x is crockery. So if it was crockery, so it will check in which condition it is fitting. It is fitting in 5, so which is correct. Okay, and crockery it is assigning correctly 5. Then in the second iteration for value in x, so second iteration the value is shirt, so shirt the value is shirt, therefore 10 is getting assigned. In the third iteration it is t-shirt, so third iteration it is checking t-shirt, so t-shirt is not there, therefore it is taking the 40 as the value. Fourth iteration it is checking the value is shirt again, and shirt it should ideally use 10. Okay, so yeah, let's see. Let's see what happens. Let me change the shirts. Okay, for crockery it is able to detect correctly. So what is happening here is it is a nested statement now. Now this is a nested conditional statement. So when we are using nested conditional statement, we have to take care how we are positioning our values. So here in this case we have to make sure what is the value. So here it was shirts, I will make changes, and now you can see it is able to correctly detect what are the values. So crockery, whenever it is seeing crockery, it is giving the value as 5 in the crockery position. Whenever it is detecting shirt, it is giving 10 as the values, and whenever it is detecting t-shirt, it is, because t-shirt is condition is not mentioned there, it will give 40 as the value. Okay, so this is how the list comprehension works. So here we are going to give a short exercise. So find strings in a list that are longer than 9 characters using list comprehension. So you can use the length function over here to work out on that.
Enjoyed the session? Don't forget to like, subscribe, and let us know what Python topic you'd like us to cover next.